So continue problem number 5 here. This clearly is again a separable equation. So what I end up with is 2y over y squared minus 5 dy. And then I end up with 1 over x squared dx. So clearly I want to fill in 2y over y squared minus 5 here and 1 over x squared here. So to find the antiderivative, I have integration of 1 over x squared dx, which is negative 1 over x plus c. The antiderivative of 2y over y squared minus 5 dy, we're going to use with substitution method. So if you had y squared minus 5 equals u, that is to say 2y dy is the same as du. So your problem on the left side is going to be changed into du over u, which in other words is log of absolute value of u plus c, which is log of absolute value of y squared minus 5 plus c, which is going to let you fill in your final answer up here, ln of absolute value of y squared minus 5 plus c. So the substitution method which we had is y squared minus 5, so du is 2y dy. And don't forget to type in your multiplication sign so you can avoid confusion, right, for the answer. And solve for the y when you have one positive solution and one negative solution. So by saying natural log of absolute value y squared minus 5 equals 1 over x plus a constant, this is try to use k. Let's change that into k later. So if we raise e to the power on both sides, its absolute value of y squared minus 5 equals e to the negative 1 over x times e to the c, which technically I could have called k. And then because of the absolute sign, I want to keep it to be positive. So y squared is k e to the negative x plus 5. Then y is positive negative of k times e to the power of negative 1 over x plus 5, which is supposed to be your final answer. So I end up with square root of k e to the negative times negative 1 over x plus 5, negative k times e to the power of negative 1 over x plus 5. So for the particular solution given to us, because it was negative, so I'm going to choose the negative one to use. So my solution is supposed to look like negative 7 equals negative of k times e to the power of negative 1 over 1 plus 5. So after simplification, you end up with 49 equals k e to the negative 1 plus 5, hence 44 is k over e, hence your k is 44 times e. So you'll be having your solution as negative square root of 44e times e to the negative 1 over x plus 5 as your final answer. So here's what I have as my final answer for the problems. Okay, so let's move on to the next one. Along the same line of thinking, it's just about separation of variables. So it's dy over dx, which equals 5 cosine of x minus y cosine of x, which quite obvious you are going to separate your expression like that. So you end up with 1 over 5 minus y dy is the same as cosine of x dx. So what you want to integrate is 1 over 5 minus y and then cosine of x here. So this is sine x plus c. The antiderivative of 1 over 5 minus y, you want to set u to be 5 minus y, hence you end up with du being negative dy, or the other way around, negative du is dy. So the left side of the expression is antiderivative of negative du over u, and the right side is pretty straightforward. I find the antiderivative already, sine x plus c. So the left-hand side is negative absolute natural log of absolute value of u. In other words, negative absolute value of 5 minus y equals sine x plus c. So I can type in my answer directly here, which is negative natural log of 5 minus y plus c. So that is to say I'm solving my y by putting those two pieces together. So I end up with 5 minus y is negative sine of x plus c, and then e to the power of that. And they said you are going to use the constant as k here. So what you end up with is 5 is, y is, let me just make sure I'm doing it correctly. So 5 minus y, well, because it's absolute value, so technically you could have said it's y minus 5. It goes in both directions. So you could have said it's the same as y minus 5. So what I end up with, if I were to simplify this, is going to be k times e to the negative sine x, and then add my 5 to it, because you want to, for this is what we are going to end up with. So, well, the next thing is to substitute your initial condition. So negative 3 is k times e to the 0 plus 5. So you can find your k, which is negative 8 divided by 1, so it's negative 8. So what you are going to end up with is a solution claimed as negative 8 e to the negative sine x plus 5. Your solution y earlier is supposed to be k times exponential of negative sine x, and then you plus a 5 to it. Okay, so because all you need is a particular solution, so all this should work out just nicely. Okay, so let's move on to our next problem. Our next problem is dy over dx equals 9y plus 8. Hence, your problem is the antiderivative of 1 over 9y plus 8. And then you have 1, so this is x plus c. The antiderivative of 1 over 9y plus x dy is supposed to be setting 9y plus 8 to be u, so 9 dy is supposed to be du, hence 1 dy is supposed to be 1 over 9 du. So the problem is supposed to be the same as antiderivative of 1 over 9 u du. So after you convert it back, it is ln of natural log of 9y plus 8, right? And there's a divided by 9, and then add a c to it. So it will have natural log of 9y plus 8 divided by 9 plus c. So if I were to convert it, if I set equal to x, or if you had x plus c on the other side, so what you could have had is natural log of 9y plus 8 is divided by 9 is x plus c. So in other words, it's 9x plus c. So what you end up with is your y is supposed to be e to the power of 9x plus c, and then subtract by 8 and divided by 9. So what you end up with is 1 over 9 e to the 9x plus c can be converted into multiplied by k because it's an unknown constant, minus 8 over 9. So this is what you have as a solution here. It is k divided by 9, but you know, having a k divided by 9, it's arbitrary constant divided by another arbitrary constant. It can be absorbed into one term, right? So what you end up with is k times e to the 9x minus 8 over 9. And if you have an initial condition, which is 1 equals k times e to the 0 minus 8 over 9, which is k minus 8 over 9, it means your k is 17 over 9. So what you end up with is 17 over 9 times e to the power of 9x minus 8 over 9 as your final answer. Okay, So let's continue with our discussion. We want to find all the first order linear ordinary differential equation. So if we glance through it, we want to rule out the thing that's not first order, right? This is second order. And we want to rule out the term that's not linear. So this is not linear, that is not linear. Right, so the rest part, let's just double check. This clearly first order. I can actually rewrite it into the standard form to help you understand it a little bit better. It's 4 over negative 4 over xy, and it's x to the fifth e to the x. So I converted into the form we prefer you to keep, dy over dx plus pxy equals g of x, right? And the next one is dy over dx plus negative 3 over sine x times y equals 0. So it's not just first order linear, it's even homogeneous. And the next piece, if I were to rephrase it, it's dp over dt, and then plus 2t minus 1p, which is the same as 4t minus 2. So I found those three as the first order linear ordinary differential equation and even converted it into the appropriate form. So the next one is we want you to find everything that applies to this particular classification of the differential equation. And well, it's relatively simple. First of all, it's linear, right? The second thing is it's separable because you end up with dy over dx, which is negative 3y, which can be classified as a multiplication between an x term and a y term. So this is clearly separable. It's also autonomous because you have 0 on the right side. What you had was y prime plus 3y, and what's most important, it has nothing that's simply depending on x. So it's 0 on the other side. We didn't really cover the logistic case. Oh, my bad. This is, I said homogeneous, right? It should have been stated there. And it's also autonomous. It's because the whole expression, as you can see, does not have x term in it, right? This is not just no x term. This has no x, and this has no constant term standing by itself, so it's homogeneous, right? So this is my classification, BDEF. So solve the initial value problem we had before with the help of integrating factor method. So the first, you want to rephrase your problem such that it looks like the structure that is so-called the standard form. And then the integrating factor is e to the power of integration, okay? They don't want you to find the structure, they want you to give me the answer. So mu of t is integration of 5 over t dt, which is e 5 times natural log of t. So after simplification, it is e to the ln of t to the power of 5, which is t to the power of 5. We only want one thing that works, so you can ignore absolute value for now. So it's t to the power of 5. So the left side of the expression is t to the power of 5 times y, right? Prime is 3 times t to the power of 5. So in other words, t to the power of 5 times y equals the antiderivative of the right side, which is supposed to be 3 divided by 6 and t to the power of 6 and then plus a c. So that is to say y is 3 over 6, in other words 1 over 2, and then t, and then c times t to the power of negative 5. So your final answer is 1/2 t, or t divided by 2 plus a c. What you need to know the constant because you also give you an initial condition. So you end up with 5 being 1/2 times 1 plus c divided by 1. So you find out that your c is supposed to be 5 minus 0.5, which is 9 over 2 or 4.5, whichever works best for you. So 9 over 2 times t to the power of negative 5 is supposed to be your final answer for this problem.